What's going on, everyone? In this video, we're going to go ahead and take a look at how we can go about optimization problems, how we can rearrange equations, substitute one variable in for another, and also graph that information and figure out how we can use our graphic technology in order to get us the answer as efficiently and accurately as possible. Let's go ahead and take a look. All right, so I'm given a very basic prompt here. I want to find the minimum surface area of a closed cylinder with a volume of 500 cubic centimeters. So what that's going to require from me is the knowledge of two things. One is that my volume of a cylinder is going to be pi r squared h. Sorry, cut that part out. And also that my surface area of a cylinder is going to be equal to 2 pi r h plus 2 pi r squared. Okay, maybe you have a formula booklet, maybe you remember that, but those are the two things that we're going to have to be working with here. So let's go ahead and focus on this first part. The volume is 500 cubic centimeters. So 500 is going to be my pi r squared h. Now, what I want to find is the minimum surface area of a closed cylinder. So what's going to be easiest for me to do is that, very similar to a problem that we covered in a previous video, link above in the description or in the corner of the screen, is that if we actually go ahead and solve this for one of the variables, in which case h, we can actually go ahead and plug that into the surface area, and now we can have a graph that represents the surface area, find the minimum point in the calculator, and figure out what the radius is that'll give us that minimum surface area. So what I mean to say is that let's go ahead and write out the surface area formula right next to it, which is that the surface area is 2 pi r h plus 2 pi r squared. And what's going to be easy is if I rearrange this equation so that I make h the subject, if I have h equals. So what that would look like is h is going to be equal to 500 all over pi r squared. Again, just divide each side by pi r squared. Now I'm going to plug that in for h, and so now that way I have, again, I am trying to find the minimum surface area. So what I'm going to do is I'm going to get surface area in terms of one variable, so that way I'm able to graph it, and that way I can see visually where my minimum point is. So my surface area here is going to be 2 pi r, again, I have h equals over here, so it's 500 all over pi r squared plus 2 pi r squared. So let's go ahead and simplify that down. Pi is going to cancel. R would just be left with 1 r, so that'd be leave me with 1,000 here, plus 2 pi r squared. So I have, over r. So I have 1,000 over r plus 2 pi r squared. Now, if we go ahead and put that into our graph, we're going to see something that looks exactly like this. Anyways, now I'm looking at my graph of 2 pi x squared plus 1,000 over x. Again, I know we're using the radius before, but in the graphing calculator, sometimes depending on which one you're using, it's easier just to keep it in terms of x and y. So either way, I have x, which is my radius, as my input, going left to right on my x-axis, and my output is going to be the surface area. Again, the problem is asking me for the minimum surface area, which means that I'm going to look for the smallest y value that I see on my graph. Okay. So when I'm using Ti-Nspire, I can go ahead and figure out what my minimum is by analyzing the graph, and I will find that I have a minimum surface area value of 349. So what that means is that when I have a radius of 4.3 centimeters, that is going to give me the smallest surface area possible of 349 square centimeters. Okay, so that's what the answer is looking for. It's asking me, hey, what is my smallest possible surface area? And also, in addition, where does that occur? And that is the radius. So radius is 4.3 centimeters. I'm going to have an output of 349 square centimeters, which is going to give me the smallest possible surface area. Okay. So I hope that helped you realize how we can go from a little one-line, one-sentence problem with one number in it and use what we know about volume and surface area, rearrange it a little bit, turn it into an equation that has just one unknown, put that into a calculator, and figure out where the minimum or the maximum value is depending on what the problem is asking for and why and what information we are extracting and why. I hope that helps, and I'll see you all in the next video.